Let's continue with number 7 in this exercise on oxidation number and oxidation and reduction. In question 7, we are asked to find the oxidation number of iron in each of the following compounds. In A, the compound is FeCl2. So the total charge of the compound is 0. You understand? There's 0 here. So FeCl2 is equal to 0. That means if you put the charge of the iron together with the charge of the two chlorine atoms, you get 0. What does that give you? Fe plus 2 times minus 1 is 0. The charge of chlorine is 0 in any of its compounds. In this compound, not in all. So Fe plus 2 times minus 1 is 0. Fe minus 2 is 0. Fe is equal to plus 2. We call this compound iron 2 chloride, since the charge of iron in it is plus 2. Same thing for number 3. FeCl3 is FeCl3 0. So FeCl3 is equal to 0. What does that give you? Fe plus 3Cl is equal to 0. That means Fe plus 3 times minus 1 is equal to 0. That gives you what? Fe minus 3 is equal to 0. So the charge of iron in this compound is plus 3. We call the compound iron 3 chloride. So FeO. Now, FeO is the same thing as FeO0. So that's what FeO is equal to 0. The charge on the compound is 0. So oxygen is minus 2. The charge of oxygen is minus 2 in its compound. So Fe plus minus 2 is equal to 0. Fe minus 2 is equal to 0. That gives you also what? Fe is equal to 0 plus 2 plus 2. So we call this compound iron 2 oxide. Let's proceed first. This Fe2O3. Charge on the compound is 0. So we do Fe2O3 is equal to 0. Sorry, I omitted the 2 here. That means Fe2O3 is equal to 0. What does that give us? That tells us that 2Fe plus 3O is equal to what? 0. So oxygen is minus 2 in its compounds, except in peroxide. This compound is not a peroxide, so the charge of oxygen in it will be 0. That means 2Fe plus 3 times minus 2 is equal to 0. 2Fe minus 6 is what? 0. Plus 3 times minus 2 is minus 6. What does that give us? 2Fe is 0 plus 6. 2Fe is plus 6. And Fe is plus 6 over 2. So that gives us what? Plus 3. We call this compound iron 3 oxide. We call it iron 3 oxide. The charge of Fe here in a lone element is 0. So we simply call it iron. Anyway you see this, you simply call it what? Iron. Also, in FeS is the same thing as FeS0. The charge of iron in the compound is what? 0. So FeS is equal to 0. What does that give you? That gives you Fe plus minus 2 is equal to 0. So Fe minus 2 is 0. That's what? Fe is equal to 0 plus 2. And that's what? What does that give you? Fe is equal to plus 2. So the charge of iron in this compound is plus 2. We call it iron 2 sulfide. I hope that's clear. Very easy. FeBr2 0. FeBr2 is equal to 0. So bromine is in the same group as chlorine. Its oxidation number is minus 1 in most compounds, or in this compound, so to speak. So Fe minus 2 plus 2 times minus 1 is minus 2. Fe minus 2 is equal to 0. Fe is what? 0 plus 2. That gives us what? Fe is equal to plus 2. And we call the compound iron 2 bromide. We call the compound iron 2 bromide. Let's continue. FeBr3 is what? FeBr3, FeBr3 is 0. So FeBr3. What do we call this? Fe plus 3Br is equal to what? 0. So Fe plus 3 times minus 1 is 0. Plus 3 times minus 1 is what? Minus 3. So Fe minus 3 is 0. Fe is equal to 0 plus 3. Fe is equal to 0 plus 3. That gives you what? That gives you what? Iron 3 bromide. That gives you iron 3 bromide. Fe is equal to plus 3, iron 3 bromide. So let's go to question G. Let's go to question G. In question G, it says we should find the oxidation number of iron in. Okay, is it not G we just did now? GH, we've done G, we've done H. So let's go to question I. In question I, we have to find the oxidation number of iron in K4FeCN6. In K4FeCN6. K4FeCN6 is the same thing as K4FeCN60. K4FeCN6 is the same thing as K4FeCN60. That means the oxidation number of iron in this compound is what? Sorry, that means the oxidation number, that means the total charge on the compound is 0. So 4K plus Fe plus Cn is equal to what? 0. Cn is cyanide ion made up of carbon and nitrogen. Potassium is plus 1. We don't know the charge of Fe. In cyanide, carbon is minus 4. Nitrogen is plus 3. So let's just put that together in a bracket. That gives us what? Plus 4 plus Fe plus minus 3. Minus 4 plus 3 is minus 1. So that gives us plus 4 plus what? Fe. That gives us plus 4 plus Fe. Plus 4 plus Fe minus 1 is equal to 0. That's what? Plus 4. Okay, let's rearrange. What do we get when we rearrange? We get Fe plus 4 minus 1 is 0. So if we get Fe plus 4 minus 1 is 0, that gives us Fe plus 3 is what? 0. I hope I'm not making a mistake here. Plus 4 plus Fe. Okay, I made a mistake. There's meant to be 6 outside the cyanide. I didn't put it. So let's go correct that mistake. This is normal. This is normal. It can happen. This can happen. So let me just correct that quickly. 4k plus fe plus 6 times, minus 4 plus 3. Okay, let's just put cn inside the bracket first and not skip steps. 6 times cn is 6, so 4 times plus 1 plus fe. There was 6 outside here. I did not include in my steps, so that was a mistake. Plus 6 times minus 4 for carbon plus 3 for nitrogen is 0. In this compound and in the cyanide ion in this compound, the charge of carbon is minus 4 and that of nitrogen is what? Plus 3. So that gives you what? Plus 4 plus fe plus 6 times minus 1 is what? 0. So plus 4 plus fe plus 4 plus fe minus 6 is what? 0. What does that give you? Okay, on rearranging, let me clean this. On rearranging, that gives us what? On rearranging, that gives us fe plus 4 minus 6 is 0. So that's fe minus 2 is 0. Fe, the charge of ion, is 0 plus 2. Fe is equal to plus 2. So the charge of ion in this compound is plus 2. We call this compound K4FeCN6. We call it potassium. We call it potassium hexacyanoferrate 2. We call it potassium hexa. We call it potassium for potassium hexacyanoferrate, meaning 6 cyanide ions, which is Cn minus, and ferrate, which is plus 2, ion, which is plus 2. So that's how we name the compound. Let's go to J. In J, we have K3FeCN6. In J, K3FeCN6. That's a simple question. K3FeCN6 is K3FeCN60. That gives you K3FeCN6 is equal to 0. Meaning what? 3K plus Fe plus 6Cn is equal to 0. So 3 times plus 1 plus Fe plus 6 times what? 6 times Cn is what? 0. Let's now spread it out properly. Plus 3 plus Fe plus 6 times minus 4. Okay, C plus N is what? 0. So plus 3 plus Fe plus 6 times minus 4 plus 3 is 0. What does that give us? That gives us plus 3 plus Fe plus 6 times minus 1 is 0. So plus 3 plus Fe plus 3 plus Fe minus 6 is equal to 0. That's Fe plus 3 minus 6 is 0. Fe minus 3 is what? 0. And what does that give you? Fe is 0 plus 3. Fe is what? Plus 3. Fe is plus 3. And that's going to give you... Okay, that means the charge of ion in this compound is what? plus 3. So what do we get? What do we have? We call the compound. Okay, let me write it again so we can name it from here. K3FeCN6. We call the compound potassium. We call the compound potassium hexacyano. I don't know whether this is 1 or 2. Should be 1. Hexacyanoferrate. It is the R that is 2. Hexacyanoferrate 3 now. In this compound, the ferrite ion is charged 3 plus. So we call the compound potassium hexacyanoferrate 3. We call the compound potassium hexacyanoferrate 3. So J. That's all for number 7. Let's go to number 8. We have to calculate the oxidation number of the underlined element in the following compounds. FeSO4. Number 8. FeSO4 is same as FeSO4 0, meaning that the charge on the compound is 0. If you put the charge of iron together with that of sulfur and that of 4 oxygens, you should get a total of 0. That gives you what? Iron is plus 2 here. We don't know the charge of sulfur. 4 times minus 2. Oxygen is always minus 2, except in peroxide. So that gives us 0. That's what? Sulfur plus 2 minus 8 is 0. Sulfur minus 6 is 0. S is 0 plus 6. The charge of sulfur in the compound is plus 6. What does that give us? We call the compound iron 2 tetraoxo. Let me try and spell this way. Iron 2 tetraoxo sulfate 6. Okay, that's what? Number 8. Now number 8b. What's in 8b? 8b is PbNO3 2. PbNO3 2. So PbNO3 what? 2. There's no charge on the compound, so we can write that the charge on it is 0. So PbNO3 2 is 0. What does that give us? Pb. That gives us what? Pb plus what? Plus in NO3 2 there's 2 nitrogen and there's 6 oxygen. Is 0. So I hope you got how this is done. There's 1 lead atom. There's 2 nitrogen atoms. 1 lead atom, 2 nitrogen atoms. Do you understand that? And 6 oxygen atoms, like that. So that gives you what? Pb is plus 2. 2 nitrogen is 2n. Oxygen is minus 2 in this compound too. So that's what? Plus 2 plus 2n minus 12 is 0. So 2n plus 2 minus 12 is equal to what? 0. 2n minus 10 is 0. What does that give you? That gives you 2n is 0 plus 10. 2n is equal to plus 10. The nitrogen's charge, or the charge of nitrogen, will be plus 10 divided by 2. And that's what? Plus what? 5. So we call this compound lead 2. We simply call it lead. We can put 2 if we like and write the trioxo. Write the trioxo nitrate 5. So we call this compound lead 2 trioxo nitrate 5. Exactly. Sometimes the 2 is not written, but it's more correct to write the 2. So sometimes in short we can just write lead trioxo nitrate 5. I hope that is clear. Now, question, that was 8b. Let's go to 8c. 8c now. In question 8c, we are to find the oxidation number of sodium in NaH, sodium hydride. In this compound, no charge is written, so 0 is the charge, and the charge of the compound is equal to 0. If you add the charge of sodium to that of hydrogen, you should get 0. So Na, this is a hydride, so the charge of hydrogen in this compound, we said that in our previous examples, the hydrogen is always charged +1 except in metallic hydrides. So this is an example of a metallic hydride. This is a metallic hydride. It's called sodium hydride. So the charge of hydrogen in it is -1. So Na -1 is 0. Na is 0 plus 1. Na is what? +1. That means that we call this compound sodium hydride. We don't really write the one, just call it sodium hydride. Sodium hydride. Let's go. D now. Question D now. Question D now. Okay, let me try and leave enough space there so my work can be neat. Let's go. Sodium hydride. We call that compound sodium hydride. So here, okay, question D is ZnSO3. ZnSO3. So no charge is written on it. ZnSO3 is equal to 0. That gives you what? Zn plus S plus 3O is what? 0. So the charge of zinc in this compound is 2. Oxygen is -2. If you put that together, you get +2 plus S minus 6 is 0. S plus 2 minus 6 is 0. S minus 4 is what? 0. What does that give you? S is 0 plus 4. S is plus 4. S is what? Plus 4. So, question E now. Question E now. Mg. Okay. Mg. Mg is the same thing as Mg0, and the charge of the atom is 0. That's just simply called a magnesium atom. Question F now. And F, it says we should find the charge of nitrogen in MgNO3 too. I hope I'm not writing one question twice. No. There's a mistake there. This was not Mg. Question E was MgNO3. Let me just leave that and write another E. MgNO3 to take this as a bonus. So in MgNO3 we have to find the oxidation number of N. This is the same thing as MgNO3 0. The total charge on the compound is 0. So MgNO3 is equal to 0. What does that give you? That tells you Mg plus 2N plus 6O is what? 0. So that's what? Mg plus 2N. Mg, the charge of magnesium in this compound is +2. So +2 times N plus 6 times -2 is equal to what? 0. So plus 2 plus 2n minus 12 is 0. So 2n plus 2 minus 12 is what? 0. That gives you what? 2n minus 10 is what? 0. So 2n is 0 plus 10. 2n is plus 10. That's what? N is what? Plus 10 over 2. N is plus 5. N is plus 5 tells you that, okay, we call this compound magnesium trioxonitrate 5. We call this compound magnesium trioxonitrate 5. That was E. Let's go to F now. Let's go to F now. In F, the compound is NaMnO4. We have to find the charge of Mn. NaMnO4. NaMnO4 can also be written NaMnO4. There's no charge on the compound, so the charge on it is 0. What does this tell you? That if you put the charge of the sodium together with the charge of the manganese and those of the 4 oxygen atoms, your total charge should be what? 0. Sodium is a group 1 element with a charge of plus 1. Oxygen is minus 2, is what? 0. What does that tell you? That tells you that plus 1 plus Mn minus 8 is what? 0. So Mn plus 1 minus 8 is equal to 0. Mn minus 7 is what? 0. That's what? Manganese, its charge is 0 plus 7. So the charge of manganese is what? Plus 7. We call this compound, the compound is NaMnO4. We call it sodium tetraoxo. We call it sodium tetraoxo. Let me write that well. We call it sodium tetraoxo manganate 7. We call the compound sodium tetraoxo manganate 7. Let's go to question G. Okay, let me space that a little bit more. Let's go to question G. In question G, the compound is NaAlO2. We have to find the oxidation number of the aluminium atom. NaAlO2. That L looks like a C. So there's no charge on the compound. NaAlO2 is the same as NaAlO2 0. So the total charge on the compound is what? 0. That tells us that if you put the charge of the sodium together with the charge of the aluminum and the 2 oxygen atoms, you should get 0. I always write this as oxygen in brackets so it will not look like 20 or 30 or 40 and so on. So that tells sodium is plus 1, aluminum we don't know, 2 oxygen is what? 2 times minus 2 is equal to 0. So plus 1 plus Al minus 4 is what? 0. So the oxidation number of aluminum here can be gotten by rearranging plus 1 minus 4 is 0. So Al minus 3 is what? 0. And what? Al is 0 plus 3. Al is equal to what? Plus 3. So the charge of aluminum in the compound is what? Plus 3. What does that give us? We call that compound aluminium. We call the compound aluminium trioxo. Okay, no. No, it's not a trioxonitrate. We call the compound, let me write it so I can remember. NaAlO2. We call the compound sodium dioxo. We call the compound sodium dioxoaluminate 3. I think that's the Oxidation number of aluminum. So what question was that? That was G. Let's now go to H. Na2ZNO2. H now. Na2ZNO2. We have to find the oxidation number of Zn. Let me be sure of that. Yeah, correct. Na2ZNO2. So let's go. There's no charge on the compound, so it's the same as Na2ZNO2 So the charge on the compound is what? 0. Na2ZNO2 is equal to 0. So 2Na plus Zn plus 2O is equal to what? 0. So 2 times plus 1 plus Zn. 2 times plus 1 plus Zn plus what? Plus Zn plus what? Plus 2 times minus 2 is 0. So plus 2 plus Zn minus 4 is equal to what? 0. That gives us what? Zn. If I rearrange, I get Zn plus 2 minus 4 is 0. Zn minus 2 is 0. Plus 2 minus 2 plus 2 minus 4 will give me minus 2. So Zn is 0 plus 2. And that's what Zn is plus 2. The compound is Na2ZNO2. Let me check again. Yeah, Na2ZNO2. We call it sodium. We call it sodium dioxozincate 2. That's what we call the compound. Sodium dioxozincate 2. So take note of that. Next is what? That was G. Or that was what letter was that? H. Next question is I. Let's go to I. In I it says AlOH3, and we are looking for the oxidation number of aluminium. AlOH3. AlOH3 is AlOH3 0. That means the charge of aluminium, the charge of the compound is 0. So what does that tell you? Al plus 3O plus what? 3H is equal to 0. Here O is multiplied by 3. You understand? H is also multiplied by 3. So Al plus 3O plus 3H is 3. We are looking for the charge of aluminum. So oxygen is minus 2. Hydrogen is plus 1. Is 0. What does that give us? That gives us Al minus 6 plus 3 is 0. So Al minus 3 is 0. Al is 0 plus 3. Al is 0 plus 3. That tells us Al is what? Plus 3. Now, Al is plus 3. We call this compound aluminium hydroxide. We don't put the 3. Aluminium. We call this compound aluminium hydroxide. We simply call the compound aluminium hydroxide. That's question 8I. That was question 8I. Let's now do question 8J now. 8J. Okay. I've been writing 8. So let me just write J. H2S, we are looking for the oxidation number of sulfur in H2S. We are looking for the oxidation number of sulfur in H2S. So here, H2S is H2S0. What does this give you? The total charge on the compound is 0. So if we put the charge of the 2 hydrogen atoms together with the charge of sulfur, you should get a total of 0. So 2 times plus 1 plus S is 0 plus 2 plus S is 0. S is 0 minus 2. The charge of sulfur in this compound is minus 2. We simply call the compound, I think we have named this before, but let's do it again. we could simply call the compound hydrogen what? Sulfide. We simply call the compound hydrogen sulfide. We simply call the compound hydrogen sulfide. We simply call the compound hydrogen sulfide. So let's continue. Okay, I think we're going to pause here for now and maybe do numbers 9 and 10 in our next video. And that's the end of this basic calculations on oxidation number of atoms, of different atoms in different elements. I'll give you an exercise at the beginning of the next video.